All right, well, my name's Colin. I'm Team Inspiration, or representing Team Inspiration today. I have been in the first progression for 9 years now. I've done FTC. This is going to be, I think, my 4th or 5th season. So I've been in here for a while, and I wanted to provide my ideas and perspectives on CAD for FTC. Now, you guys have put a lot of intermediates and beginner, or a lot of intermediates on chat. So I'll sort of address it to the crowd, and you guys have highlighted your CAD software as Onshape and Fusion. So again, I'll be addressing it to the crowd, but I want to keep this maybe a little bit more high level, right? I won't be going into the details, the procedures, unless we have specific questions on those. So here's the agenda. I'll be going over the effectiveness of CAD. So why CAD? Go through the uses, compare the softwares real quick, provide demos, and then throughout this presentation that will be linked later today on the website, it's going to be riddled with all these links to all the resources that I've used. So first, why CAD? CAD is embraced everywhere and even in FLL. So global teams across the world, they want to push themselves to the next level. So instead of, hey, how can I go at the prototype, right? They build their robots with the Lego part library. They assemble them with Lego Digital Designer. And something that's here, you can see they have all their parts on the left, all their things on the right. And this allows them to put all their pieces together and then download the step-by-step instruction on how to use it. So CAD is super powerful, computer-aided design, super powerful. Now it's embraced by FRC. So that's the level above. FLL was the level below. You can see here, beautiful renders. You can see for every subsystem, we have the lift, collector, climber, drivetrain, full robot, a second collector, a third collector, another gearbox, and then one more gearbox. So you can see CAD, the tippity top is that every single subsystem will be created on their robot. And now CAD is embraced by FTC. So you can see here an alumni, he built this in 1 week. Right after the season was announced, he jumped into his CAD software of choice and whipped together a robot. You can see that it has all of the pieces, the whole idea of the robot, and everything is included on there. And this was done in a week's time. So we'll go over the best practice or the benefits of this. You'll be able to use advanced manufacturing capabilities. You'll be able to compile bills of materials and identify lengths of cuts before you cut. And then it also helps you visually represent your robots and mechanisms in the engineering notebooks. So that is why CAD, and it's embraced by every single level. So I can open it up for questions. You guys have any comments, concerns, any ideas that you guys want me to discuss in this presentation? Can either drop it in chat if that first half made any sense to you guys. All right, well, silence will allow us to continue. But you can see here, one of the best things that I mentioned, one of the best reasons for CAD is for the communication process, right? Crash Test, they had a phenomenal presentation on how they started and really collaborated inside the team to get everyone on the same page. So they would open their file in Onshape and they could collaborate on that same file. But now, how do you communicate your designs to the judges? How do you communicate your designs to the public? So because this is Zoom, you guys actually can take your phone out and scan the QR code, and this is going to redirect you to an interactive model of CAD. And this is super exciting because you can put this QR code on your engineering notebook, on your outreach banners, even on your website, so that people who have had no experience with 3D modeling software can take their phone, engage with your engineering notebook, and then be able to rotate around your 3D model. Obviously, this QR code is just a redirect of this website here. Pardon, that is not the website. Okay, that is something that I will have to update. But right now, visually on screen, you'd be able to, or actually, I should take that back. I'm always prepared. So on screen here, you can see that interactive CAD model. This is what the hyperlink or the QR code will redirect you. And you can now pan, orbit all around your CAD model. And you can even do this on your phone. So this is a super powerful tool in communicating your designs and really engaging people into your hard copy documentation. Now, going over the software, really 3 things that stand out to me is SolidWorks, Autodesk, and Onshape. And really, I like to think about this as SolidWorks as being super powerful for top-down assemblies. So for something like spaceships or FRC projects such as this, where you have to have a lot of detail on every single component, SolidWorks is the way to go. It's less in cloud computing, so it's harder to collaborate, but people have workarounds for that more powerful top-down assembly. Autodesk Fusion 360, this is the one that I was brought up. This is the software that I learned in just a week, so it was super simple to use. And now Onshape is almost taking over Fusion 360 in their collaboration aspects. But and this is all browser-based, so you don't even have to download anything to get this CAD software up and running. And here I've linked out Game Manual 0, where veteran teams have provided their sort of ideas on which CAD software is the way to go. But again, this presentation is supposed to be high level, so I'll be going over my best practices and ideas and preferences that you can set up on your software to be able to migrate across all of these platforms. All right, so demo time. I have included 2 shortcuts for you guys to remember. So it's going to be the super shortcut S for the super search bar, and then the control click. So what do I mean by that? Let's get Fusion up and running on this, and let's just open up a demo. So you can see I'm opening up a cylinder. Now, if I can control click, right, I'm able to select multiple things, as you can see on the screen. And this is just going to make your life a little bit easier because shift clicking does not necessarily work. And then there's all these confusing bits up top, all these confusing bits on the bottom. It's all streamlined with the Super S search tool bar. I can click S and type in anything I want to do. So if I want to create a sketch, I can type in sketch. Voila, I can create that sketch. If I want to do appearance, I can press S and then type in appearance. Voila, I can go to my appearances taskbar. So Control S, or pardon, just clicking the S button on Fusion works for Onshape as well as SolidWorks. You're able to search up for all your components, and you're able to customize this as well, so that you have all of your shortcuts accessible in one click of a button. So that was the super search bar S shortcut for you, and we'll continue on. And we'll go over the UI. So user interface of Fusion 360. One of the things,
Colin.
Yep.
Suggestion. Good information, but slow down the pace a little bit when you're talking. It was a little bit super fast, but same information, but just slow down a teeny little bit.
Okay.
I thought it was fine.
All right, thank you, Alex, for your input. But again, those 2 things, right? If you don't remember anything else from this presentation, remember Control click for multiple selection, and the S, and my mnemonic device for memorizing, clicking S on the keyboard, super search toolbar. But now we can continue on. I'll go over the UI of Fusion. So here we'll actually get started with the overview. So on here, these are on the left side, this is going to be sort of your taskbar of all of your projects that are staged to be used. So, and anyone can collaborate on this because Fusion 360 is a cloud software. I can double click here and any of the designs that I've curated earlier will pop up on screen. Next part is the preferences and help. So here, my profile, I'm able to open up my Fusion 360 profile on a browser. Preferences here, I'm able to go in and select anything that I want to configure with. So for example, I can convert my initial units to metric or keep it in imperial. We'll go over the benefits and disadvantages of that. One thing to note is that you can see here, I've changed my pan, zoom, orbit shortcuts to SolidWorks. And this is so that when I pan or translate the perspective from X to Y, I'm using the control middle mouse wheel. And when I orbit, I use the middle mouse wheel. And this is so that when I transition to Onshape, Fusion 360, Inventor, SolidWorks, I can always go in and still retain that same sort of shortcut methodology. There's no learning curve if I put all of the shortcuts to be that super S search tool, control clicking for selecting multiple things, and then turning all of my movement options to SolidWorks. It's super consistent, so I'm able to jump around all those CAD platforms. Next, what we're going to be going over is the toolbar up here. So what you don't know is obviously an unknown. So if you want to maybe take a gander over here to all these sort of things, you can sort of take a look at what options are provided to the user on this top toolbar. And then if you don't know, right, they have the description here and you can obviously search it up. But all these items here, the extrude, revolve, sweep, loft, rib, web, emboss, for example, can all be accessed with that super S shortcut toolbar. So I can search up extrude right there, revolve right there, sweep, right? So I can navigate through this whole entire top portion just through using that super shortcut of S. All right, so the browser here, now it's going to be on this side of the screen, as you can see here. One of the things that I like to equate to is this is like your folder structure on your computer, right? So if I wanted my files for Word, for example, they'd be here. If I wanted to maybe find my files for Google Chrome, they'd be here, right? So think about the browser as your file explorer on your local computer. It all determines what is shown on here in the canvas. So that segues next. We have our canvas here, and this is where all the components are brought in. This is what I like to think as your piece of paper that you get to work with. What your changes and parameters that you put onto the canvas will show up. And to navigate around here, we have the view cube on here. So this allows you to normal to face or align the face up to your perspective. And this allows for 2D sketching here. So the view cube is on the top. Here, let's continue down. We've talked about the canvas, and then now we have our navigation bar and display options. So going over the display options, I have my layout grid. I can select multiple views, right? All of these things are provided to me. And even if I'm a dark mode enthusiast, I can go dark mode for all your programmer needs here. So those are just some of the quick things on the display options here. And then obviously we have those shortcuts of orbiting that we talked about, panning that we talked about. And I was able to, again, orbit with the middle mouse wheel and then pan with control middle mouse wheel and click and drag. All right, and then one more final thing for those experienced members with Fusion 360. Quick note, if you go to display settings, you can uncheck all work features and it automatically turns off all joints for you so that you don't have to look out and try to disable everything. But that was a small tidbit for the more experienced people in the room. And then finally, at the bottom here, we have our timeline. So this was the order of operations that things were created in this file. So if we click this timeline scrubber here and scroll all the way here, you can see I've started the first steps of creating our part, and all these timelines through here was just me importing existing parts from the CAD's library to verify my geometries were correct. Okay, so that was super complicated. I went over the entire UI, but pretty much one thing I want you to consider, right? This is on the left side is where the collaboration happens between team members. On here, the browser is where all of the settings on the canvas is in control, right? Our toolbar can be accessed by the super shortcut S search bar that will allow you to search for anything on here within the toolbar, and then our globe is right here. And finally, view options. I've turned off grids as well so that it's super easy for me to take a screenshot of this and copy and paste it right into our engineering notebook. All right, so that covers the UI of Fusion 360. And again, this is very similar. The high level concepts are very similar if you go to Onshape, SolidWorks, or any really CAD system that you want. My mantra is learning by doing. So if you guys want to boot up Fusion, hopefully it won't crash your computer while you're on Zoom. But hey, I like to go through just trying it out. So here, this is going to be the procedure that I'll be using to create a cylinder. It is really involved here. It's really complicated looking at it in text, but I can assure you going through it with you guys is going to be super cool. And I'll actually drop the link in chat if you guys want to take a look at this presentation and follow along. Can I copy paste it? All right, so we're on slide 22. We're going to be creating a cylinder. So first thing that we're going to do every single time that we start a new document, we're going to save it with our Control S command, or this printer icon up here, cylinder. And that is automatically going to populate a new file on the left side of our file explorer. The next step of any document is I'm going to use my super shortcut S, and I'm going to type in sketch. So this provides me 3 views here, and when I click on a plane, it's going to put me normal to that face. So looking directly on it, I'm going to then press my super shortcut S search bar to click C. All right, so again, I press the super sketch shortcut, and I can type in either making a circle, or I have linked it up here, making the circle here. I can click once, click twice, and that's going to put me on an unconstrained circle up here. So now you may be wondering, what does unconstrained mean? Well, we're going to skip ahead and save that for later. After I've created my sketch, which is normal onto a plane, so flat on a surface, I'm able to finish the sketch, press the super S shortcut, and type in extrude, so that I'm able to click on my sketch that I want to extrude, pull up, and then press OK. And voila, that's your absolute first component. That was so simple. I showed you the text. It's sort of scary, but then I showed you it, actually me doing it, and it is super simple. The more repetitions you guys can do this with, the better it is, and the more proficient you guys will be in there. Now we can say, hey, why is this unconstrained? Well, if I go back to my history toolbar here, I can edit the sketch by right-clicking edit sketch, and it is unconstrained because I can twist all around this. So if this was a hole in a plate and someone accidentally edited the sketch and pulled, right, and we then cut the plate, this hole would be completely off. So to constrain something, I'm going to use my super S shortcut of S. I'm going to type in dimension right there, click enter. I'm able to click the edge of the circle and click again. And now my circle is going to be constrained to 75 millimeters. So now if I click and drag, anyone could accidentally open up and start editing the sketch. But if I try to edit it, it's not going to change. And this is so we have consistent geometry during manufacturing. Okay, and that's the same thing here. You guys didn't realize, but we actually constrained the sketch when we extruded it. And that is so you can see here, I'm unable to click and drag to edit the part's geometry, and that allows us for consistent modeling. All right, so that was a lot. Do you guys have, for any of the newbies in chat, do you guys have any questions on my procedure of using the super shortcut S to search for all of my options? So that was sketching, extruding, and constraining. Do you guys have any questions? All right, so we'll continue on. So now again, trying by, I guess doing it by trying is what the goal is of this. So right now, a pulley holder. What is the application of a pulley holder? I'll be guiding you guys through this, but let's start off with the video. What is the pulley holder? You can see here on last year's game, Sky Stone, a pulley holder will allow us to actually elevate a lift, right? So we have strings going throughout, and when we reel in the string, it lifts up the lift. And what you can do is you can search up any mechanism online and you'll be able to reverse engineer what is needed. So I can see here, these orange pulley holders, this is what I am gonna want. So we can start with the sketch process here. If you guys actually go on to slide 25, so I'll put the link in chat. Here are all the dimensions if you guys want to follow along. Slide 29. Oop. Voila. All right, so let's get it started. So I am going to save this cylinder. I'll just save it as created, and let's start a new document. So the first step of just starting any design is that I'm going to save this. And what we're going to call it is, I'm just going to give it a date that's pretty descriptive, and pulley holder tutorial. All right, super cool. Now the second step of any document is now to use that super shortcut S. Let me organize my screen here a little bit. Super shortcut S. So when I press S, I type in sketch. I click the bottom plane here, so I'm able to set my view normal to it. I'm then able to select my super shortcut S again, type in line to draw a line. I can then single click once, 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 and single click once. And voila, I've started with my first step already. So you guys can see here that I've already completed my first step of putting that base sketch down normal onto plane. So now let's see what the dimensions are going to be. Can you guys actually help me out? Can you guys maybe help me read out the dimensions? Alex, you from Roboctify, can you read me this first dimension up here? Maybe not. Okay, I'm sort of sad. But yeah, so this first dimension here, I'm going to press S for our super shortcut. And this is going to be our constraint. So I'm going to put dimensions. I'm then able to select here, and I'm going to be able to press 10. All right, so now we can zoom in by scrolling with our middle mouse wheel. Our next dimension is going to be 9. So clicking from here to here, 9 millimeters. Oh no, we have this crazy angle that we have here. So this is 9 degrees. And the reason why is that I did not put down my sketch constraints. So one of the things here is that you guys don't have, at the toolbar up here is all of our sketch constraints. So we have horizontal, vertical, all these fancy words that my favorite tool, Google, helps me to clarify. So I click perpendicular, I can select these two lines and it creates this perpendicular 90-degree angle. So now when I try to make my dimensions again, I can then sketch dimensions, click here, and 9. And that's going to be the correct constraint. This next one is going to be 12 millimeters. This next one is going to be 3 millimeters. This one's going to be 3 millimeters. And this one, I'm going to use another sketch constraint here because these two lengths have to be exactly the same. I'm going to use the equals constraint up here. All right, super cool. Now we can finish the sketch. If we want to go onto our browser, our first sketch here is labeled sketch number 1, and I'm going to call this base. And then now what our next step is to use our super shortcut to press extrude. So again, that was S. I have it extrude here, right here, and I also have it included here. So I'm able to select that, and the next one is going to be 15 millimeters. Yep. All right, so I'm going to use a globe to normal myself to this face and use these arrows to rotate around. I'm going to use my super S shortcut to then create another sketch. And I've selected the face that I want to normal to. Now we're going to go into construction line. So I'm going to be using my construction line here and selecting a line and drawing it through the midpoint here. So you can see these triangles come up here, and that ensures that this line is directly in center of the box. So now I'm going to select my super shortcut S, create a hole here and a hole here. And these two are going to be not construction. But let's first understand why we want construction lines. Now, if I try to extrude here, it's going to extrude the face. What I want is to extrude the hole. So I'm going to right click here and edit the sketch. What happens if I make these not construction lines, so regular lines? Right now, it understands that that is a geometry that I want included in my design. So I can then edit the sketch again, and I can use another construction line because I know that it will not be determined or not implement this into the extrusion or the create geometries. I'm going to change this to 12 millimeters. I'm going to change this hole to 3.2 millimeters and change this hole to 3.2 millimeters. All right, do you guys think we're done with all the constraints here? Do you think everything is constrained? Let's see, you guys could either put it in chat or maybe tell me and unmute. No, okay, Jacob, how can you help me out? What do I need to still constrain?
The blue.
The blue one, exactly. That was exactly what I wanted you guys to pick up. So the reason why we make everything based off of our origin is that everything that is constrained, right, is going to be turning up black, and everything that is blue is going to stay blue, or is unconstrained. So we can add in another geometry here. That was at the wrong angle. I'm using Control Z to undo. So again, let's select here and do 4 millimeters. All right, so we finished the sketch here. Now, what I'm going to do is use my super shortcut S search toolbar, and I'm going to press the extrude button. So here, I'm then going to shift, control click here and control click here. And then I'm going to go over here to the options that I have on extrude. I can either use the arrow here to select, or the other option is I can select the two objects and click a face. So that whenever this thing is created longer, it's automatically going to adjust and I don't have to worry about anything. So we're going to press OK. And then the final thing that we're going to do is use that super S shortcut for the fillet. So here, if I do a fillet here and oh shoot, I forgot one of the fillets because they're going to be a fillet on two sides. So hey, what if I try shift clicking? No. I cannot do it. So that's why I told you control clicking here. So if I control click, I'm able to select the next edge of my item that I'm able to finish the fillet. And voila, that went through the entire process of using the Super S search tool to start and search up for all the items in your toolbar. So that's the create and the sketch. And then I was able to then use control clicking to select multiple edges that I was able to apply features to. All right, are there any questions for the newbies? Any comments from the experts that want to maybe provide their suggestions and experience with that workflow? All right. Super cool. So now I'm going to save this with the Control S function. I'll just provide a description created part. And we will move on in our presentation. So one of the things that I want to forward you guys to is resources to learn CAD for FTC applications. Recently, this FTC team primitive data 18219 has provided this comprehensive tutorial series on every possible thing that you would need to know to learn Fusion 360 for FTC application. So I just went over basic sketch tools and then also basic create tools for you guys. And that will allow you guys to create nearly anything from that 2D surface. And that goes all the way down, their tutorial goes all the way down for FTC managing large assemblies. So that's a great resource here on slide 26. All right, and now if we continue going on, we have Fusion 360 for educators, for the newbies that haven't been able to do it. You can click the Get Started button here. You can sign in, but it provides so many resources to first teams. Pardon, I skipped a couple of slides ahead, but you can see here, if I go onto first homepage, I click Autodesk and I'm able to start here and look at all the resources that First has endorsed, Autodesk has endorsed First with. All right.
Colin, can you go back to the first FTC, the one you did earlier? So for all the team members, they actually have the class also. So you go and click the class. You can sign up for the class. It doesn't cost you any money, but they are introduction for the class and all that. Something for especially new team member, even experienced team member. It's good to just go register for the class and sign up and go through some of the tutorial. Back to you, Colin.
Okay. So that's going to conclude the basics part of my presentation. So do you guys, for any of the intermediate or experienced people, do you guys have any questions, any maybe perspectives that you want me to share my perspective about? Or maybe even for the beginners, if you guys want me to go over the workflow again. Oh man. Okay. Well, I guess we'll then be able to go through the rest of the resources for the presentation. Again, this is all going to be recorded and uploaded onto the SDFTC website. So you guys will be able to reference this all the way down below. But one of the things to get started with is you want to have everything uploaded onto your Fusion. So what you want all the parts libraries. So I've actually recorded a video overviewing that. So you guys can take a look at this on how to set up Fusion 360 with FTC part libraries. You guys can take a look through here. But very simply, to summarize, is that we want to download this beautiful parts library that FTC team Hazmat Robotics has provided to us. And then we want to open up our screen side by side, create the file structure, and then upload all the files into our Fusion 360. And this is so that if we want to maybe get a Rev pulley from Rev Robotics, we don't have to open up the Rev Robotics site and scroll down to their pulleys and scroll down to download their CAD files, we simply have it here. So if I search up red pulley, you can see, voila, pulleys come up, and this is a pulley that I want. So now in this phase of the presentation, I'll be going over on how to verify geometries by importing components. So you can see here that I have created my pulley tutorial. I'm actually going to create a new file, and I'm just going to call this assembly pulley holder assembly. And what this allows me to do is keep this tree of creating I'm going to keep it clean, right? So I don't want to corrupt this by importing my assemblies or parts into here, but rather I would want to import everything onto an assembly document. So I can right click and insert this into my most recent design. You can see here that I, again, am not corrupting this history tree. I'm then able to insert all of my necessary components that I want to use for assembly. And that is using this sort of file explorer tree. And I'm able to right click, press insert into the design. And now we're going to be going over joints, and this is going to allow us to verify our geometries. So I'm going to able to use that Super S shortcut, select and joint, select here on the pulley, and select here on my pulley holder. And I'm able to reverse the direction here. Again, it's a little bit different terminology across platforms. For SolidWorks, it's going to be called mates, and it's going to be called a different diction for Onshape. But again, we are constraining, or if I'm able to, theoretically, if I were able to select here, I'll be not able to drag. All right, so let's continue on. So I'm able to then select a joint for all my other components. Let's select here. So I click on the face, click on the central point, and click here. Press OK, and rinse and repeat. So press S, joint, select this face. Oop, that's the wrong face. Select here, select the center, and then select my circle here. So this really quickly allows me, without any time spent on 3D printing, I can verify that, hey, my geometries are correct or my geometries are incorrect. You can see here, my pulley here, it is super squashed up, so maybe that string is not going to fit. And what's best about it is I can go over to my base or my browser here, right click and open this file. And this is automatically going to redirect me to that original file location here. I'm then able to select my base and say, hey, this should be a little bit longer. Let's make it maybe add 2 millimeters. My base will update. I can finish the sketch here, save this document, updated length to allow for string. Close this down with the Control-W command. And now this link is updated here. I can click update, and voila, automatically 2 more mils have been added to this to accommodate for the string. All right. Now you may be wondering, hey, Colin, what is a component and what is a constraint here, right? Because I'm still able to move this all around, and that is not ideal. And the reason is that this is a body. Pretty much, I want you to take this in mind. You need to convert your bodies to components to constrain everything. And that is a very Fusion 360 idea, prepping your things to be assembled, right? That is only what happens in Fusion 360. So what we're going to be doing here is I'm going to right click open our pulley. And here, what I'm going to do is right click our body and create components from body. Now, what does that do? This solidifies all of my sketches, right? So if we roll back here, I've completed all the features that I wanted to add onto this item. I've created a base sketch, extruded a second sketch, extruded, put the fillets in, and then created the component for bodies. And now that allows me to really constrain everything. So if I was going to save this version description, I'm going to say convert to component I'm going to exit out of here, and I'm going to click this magical update all linked drawings. And you can see all of these joints aired out. And that was because I initially edited let's see. We could go 1 and number 2. I could maybe redo this. Oh no.
Hold on, yeah, 10 more minutes.
Yep, so this is just a great perspective on why you guys want to convert your items to components first before you start integrating. So if you don't run into something like this where all your joint features have been aired out, right? Because you didn't convert to components before you started assembly. All right, I'll open it up for questions one more time to see if you guys had any questions on what I just said. And if you guys want me to review anything or go through anything, any ideas that you guys had about CAD using Fusion 360. Okay, well, I'll prompt with one question. So you could say, hey, Colin, does all of this really translate onto Onshape here? You told me that we're going over a high level. So I will prove it now to you. I'm bringing up Onshape right now. So here is an Onshape right here. I'm going to open up, create a new document. I'm going to call this pulley holder. And what this will allow me to do is that I've configured my account to use those same SolidWorks commands. So control and using the middle mouse wheel will allow me to pan. Using the S shortcut tool, I'm able to bring up that super short search bar, and I'm able to select my sketch. I'm able to then select my sketch plane. I'm able to then use my super sketch tool to allow me to create my lines. All my constraints are up here, so I'm able to select my constraints, use my super shortcut search tool here to constrain everything. And this will, so you can see all these things are super related. I'm using the same ideas. S, select my tool from the toolbar, constrain the sketch. Like so. We can.
There's a question in the chat, by the way.
Okay, thank you so much. What do you think of the advantages of Fusion 360 over Onshape are? Well, that's a great question. One of the things about Onshape is that you have to go to the App Store to download all of these items, right? So if you want to simulate, if you want to make heat profiling, if you want to do all this electrical documents, you have to download all those things on Onshape. But on Fusion 360, I can do all of my renders, animations, simulations, manufacturing. They're all compiled into one. And I even can do surface, I can do sheet metaling, I can prep things for laser cutters, 3D printers, you name it, Fusion 360 has an application for it. Now, Onshape, it is maybe a more powerful collaborative tool, but you have to download all these extensions to explore. So Fusion 360 is like a one-stop shop. So if you're a little bit hobbyist, but if you want to maybe explore more collaboration tools, maybe consider Onshape. This is a great question. Keep them coming. We have 6 minutes left. Coach, you're muted.
I guess you can either finish editing the rep beam or finish your presentation on your reference.
Okay, super cool. All right, so actually, yeah, let's do both. Actually, let's complete constraining all the verifying the geometries, I'm going to type in extrusion. And because I've uploaded all the parts library onto Fusion 360, I'm able just to simply right click, insert into current design. I'm able to then select this face with a joint, select this face through here, and going through this face on here. And you can see that initially constrains this item, and I can type in 5.5 millimeters, and that is going to verify. So now I'm able to actually inspect everything. So if I select everything, I'm able to actually inspect and check for interference through here. So you can see no interference is detected, so nothing is binding on one another. If I were to edit this, edit the joint, and if I didn't extrude it enough, so maybe, or move it enough, and I selected everything for inspecting, right? You could sort of see here, we have interference and it automatically tags here. So that sort of completes our geometry verification. So again, that was converting everything to components, creating a new file so that you don't corrupt your history tree, and then using that inspect tool. So I will want to maybe show you why you want to separate out your files. So this is my first attempt. You can see all my history tree is combined of doing the parts verification and the parts creation. So you can imagine how complicated this would be getting. This would get, but you can see here with my newest version, it's separated my history out into verification of geometries, and then also here of creation of parts. And this has an added benefit is that here in this super long timeline, I would have to isolate this, save this as a new file. But because I've already separated out my files, I can go up to here and export as STL. So I don't even have to worry about any extra steps of post-processing because all my files are divvied up. All right, so we're coming really close to the end of the presentation. So some final notes, please, 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 please take a look at this resource. I cannot emphasize the benefits of learning by doing. I learned Fusion in 1 week, and that was because I was tasked with building a sensor holder, and my team would have failed if I didn't complete it. So I just looked up some quick tutorials, grasped the basic concept, and just practice, practice, practice. There's a lot of tools that you guys can get Fusion 360 for free, and this will allow you to have 3 years, or now I think it's almost indefinite, of your student life to have access to these Autodesk files. There's a lot of resources from FIRST, and Fusion Autodesk is actively working with alumni of FIRST to create resources for FIRST teams. And now this is the final slide. Again, QR codes if you guys want to maybe follow us or follow up on our progress. All right, last 100 seconds left. I'd like to thank you guys so much for attending the presentation. Again, links will be in chat and then also on the FTC website for future reference. Thank you guys so much for attending.